Where is here? Imagine if here was not Earth but Europa, Jupiter's icy moon. But why Europa? And what challenges and wonders would humans face if they set up camp on this distant world? The allure of Europa, the sixth closest moon of Jupiter, has always intrigued scientists. Not just because of its ice-covered surface, but because beneath that icy shell, a vast ocean is believed to exist. This ocean might contain more than twice the water volume of all of Earth's oceans combined. But what's even more fascinating is the possibility that this ocean might just harbor life, and where there's water, human imagination and ambition flow. Europa is not just a cold place, it's exceptionally frigid, with average surface temperatures plunging to about -160 degrees Celsius. It's far colder than the chilliest places on Earth. Imagine the coldest day you've ever experienced, and then magnify that sensation many times over. Such temperatures would make any direct human activity on the surface nearly impossible. The tools would freeze, machinery would malfunction, and human life would be at severe risk. But the cold isn't the only challenge. The surface of Europa is encased in an ice shell, which could be between 15 to 25 kilometers thick. Breaking through this formidable icy barrier to access the underlying ocean, or even just to set up a base, would require advanced drilling techniques and equipment resilient enough to withstand the cold. Then there's the issue of radiation. Jupiter possesses a powerful magnetic field, which bathes Europa in high levels of radiation. This radiation is much more intense than what we're used to on Earth and poses a serious health risk to any potential human settlers. Long-term exposure can lead to severe health complications, including an increased risk of cancer. Therefore, any habitats on Europa would need to be shielded effectively from this radiation. The thick ice layer, though a challenge for access, could be a potential shield against this radiation, making subterranean habitats more feasible. Europa's atmosphere is also significantly different from Earth's. Primarily composed of oxygen, it's extremely tenuous. This means that it's far too thin to support human life as we know it. Settlers on Europa wouldn't be able to step outside without a spacesuit, and habitats would need to be completely sealed and possess their own life support systems to provide breathable air. Europa's gravitational force is only about 13% of Earth's. While it may sound fun to bounce around in low gravity, the long-term effects on the human body are not fully understood. Prolonged exposure to low-gravity conditions, as observed in astronauts, can lead to muscle atrophy, bone density loss, and other health concerns. Thus, innovative solutions would be necessary to help humans maintain physical health. Finally, for all of Europa's abundant ice and potential water, many other essential resources would be scarce. Vital elements and minerals needed to sustain human life and technology might be missing or hard to extract. Reliable food sources would also be a significant challenge. Settlers would likely need to rely on shipments from Earth or develop advanced hydroponic and aeroponic systems to grow food underground. Imagine an endless expanse of water, stretching as far as the eye can see, hidden beneath layers of ice. This isn't a scene from a science fiction novel, but a reality on Europa. This moon of Jupiter has a subsurface ocean, believed to contain more than double the volume of all of Earth's water combined. And where there's water, there's potential energy. Europa is in a gravitational dance with Jupiter, a massive planet with an exceptionally strong pull. As the moon orbits, Jupiter's gravitational tug warps and stretches it, generating heat through tidal forces. This heat ensures that Europa's underground ocean remains liquid and doesn't freeze solid, but it also presents an opportunity. These same tidal forces could potentially be harnessed, transformed into thermal energy, and then further converted into electricity. It would be a continuous source of power, much like how we harness tidal energy on Earth, but on a much grander scale. Beyond tidal forces, there is evidence to suggest that Europa may possess underwater volcanic activity. On Earth, underwater volcanoes or hydrothermal vents spew forth immense energy. If such vents exist on Europa, they could potentially serve as an additional energy source, providing heat and possibly driving turbines to generate electricity. Moreover, these hydrothermal vents could create nutrient-rich pockets in the ocean, sparking intriguing conversations about potential life and offering resource opportunities for human settlers. Europa's icy surface is constantly bombarded by solar radiation, a process that splits water molecules into hydrogen and oxygen. With the right technology, humans could potentially capture and store these gases. On Earth, hydrogen is already being looked at as a promising clean energy source, and with oxygen present, the necessary ingredients for combustion are readily available. In essence, Europa itself could provide a renewable fuel source, given the right infrastructure. Water, besides being an essential component for life, can be split into hydrogen and oxygen through the process of electrolysis. While this method would require an initial energy input, once an energy infrastructure based on tidal or volcanic sources is established, the vast ocean of Europa could serve as a vast reservoir for producing fuel, power, and breathable air. Harnessing energy on Europa offers exciting possibilities, not just for sustaining a potential human colony, but also for understanding and tapping into natural processes that are different, yet eerily familiar to those on Earth. When we talk about oceans on Earth, we imagine vast expanses of salt water teeming with life, stretching from one horizon to the other. Now visualize an ocean entirely concealed beneath an icy shield, in perpetual darkness, untouched and unexplored. This is the enigmatic ocean of Europa. Europa's outer shell is a protective layer of ice that varies in thickness but can be several kilometers deep. Beneath this icy armor, the vast ocean, possibly containing more than twice the water volume of all of Earth's oceans combined, remains hidden. The challenge would be penetrating this layer, a task that requires innovative technologies and methods to ensure safe passage through the ice and into the waters below. One of the most exciting prospects about Europa's hidden ocean is the possibility of life. On Earth, life has been discovered in the most inhospitable places, from the deep oceanic trenches to acidic lakes. The question arises, could Europa's deep, dark ocean, potentially warmed by thermal vents and rich in minerals, support alien life forms? Discovering even the simplest microorganisms in these waters would revolutionize our understanding of life's tenacity and the potential for existence beyond Earth. It's speculated that over time, the movement of Europa's icy crust may have created a complex network of tunnels, caverns, and pockets filled with liquid water. These could serve as oases for life or sheltered habitats. For human explorers, these subglacial pockets could offer access points to the deeper ocean, as well as potential safe havens or bases from which to conduct scientific research. If we were to find signs of life, no matter how primitive, beneath Europa's icy crust, it would raise significant ethical questions. Would we have the right to colonize and utilize resources from a moon that already harbors life? How would such a discovery reshape our cultural, philosophical, and religious narratives about our place in the universe? Europa's mysterious hidden depths beckon us with both challenges and promises. As we gaze upon its cracked, icy surface from afar, it's almost as if the moon is inviting us to uncover its age-old secrets, waiting patiently for someone or something to listen to its story. The idea of humans setting foot on a distant moon around Jupiter would be, in itself, a monumental event in our shared history. Imagine then what would happen if life were discovered beneath the thick ice of Europa. It wouldn't just be a scientific breakthrough, it would be a cultural and psychological game-changer. Living on Europa would mean adjusting to an environment vastly different from Earth. The constant darkness, the isolation from other human settlements, and the potentially claustrophobic nature of life beneath the ice could have significant psychological impacts on colonists. Addressing mental well-being would be as crucial as ensuring physical health in this extreme environment. With advancements in technology, the initial bases on Europa could expand into bustling colonies, with entire ecosystems being built beneath the ice. Advanced drilling and construction techniques might enable habitats to be developed closer to the moon's subsurface ocean, allowing for easier exploration and resource utilization. Europa's vast ocean might not just harbor life, it could also be a treasure trove of resources. The extraction of minerals, gases, and possibly even new, previously unknown materials from the ocean and the ice could support the moon's economy and even be exported back to Earth or other space colonies. The challenges of living on Europa would drive rapid advancements in technology. From advanced drilling machinery to submersible exploration vehicles and life support systems, the technological innovations from a Europa colony could benefit other space missions and applications on Earth. As the colony on Europa grows and establishes itself, it could play a pivotal role in the broader human expansion into the solar system. Being a midpoint between the inner and outer solar system, Europa could become a hub for trade, research, and exploration, bridging the gap between planets and fostering interplanetary cooperation. The future on Europa holds infinite possibilities, painting a picture of humanity not just as residents of Earth, but as true citizens of the cosmos. Venus, often dubbed Earth's sister planet because of its similar size and proximity to us, has always been somewhat overshadowed by our red neighbor Mars in the quest for extraterrestrial life. However, a recent discovery has cast a surprisingly bright spotlight onto this scorching, cloud-covered world. For the longest time, Venus was dismissed as a possible haven for life. With surface temperatures hot enough to melt lead and an atmosphere thick with carbon dioxide and clouds of sulfuric acid, it seemed an unlikely place to find any signs of life. But the universe, as it often does, threw a curveball at us. In 2020, scientists made an announcement that caused quite a stir in the astronomical community. They had detected traces of a gas called phosphine in the clouds of Venus. Now, why was this discovery so groundbreaking? Phosphine is a molecule made up of phosphorus and hydrogen. On Earth, this gas is primarily associated with life, produced by bacteria living in oxygen-free environments. The clouds of Venus, where the phosphine was detected, have temperatures and pressures that are somewhat Earth-like compared to the planet's inhospitable surface. This led to the tantalizing possibility: could there be life floating in the Venusian atmosphere? Before jumping to conclusions, researchers meticulously looked for other explanations. Volcanic activity, lightning, and even meteor impacts were considered as potential sources of the phosphine. Yet, none of these scenarios could produce the amount of phosphine that was observed. The instruments and methods used to detect the phosphine underwent rigorous scrutiny, with teams double-checking data and ensuring the signal was genuine. The presence of phosphine doesn't confirm life on Venus, but it does open the door to this exciting possibility. To find more answers, missions to Venus are now being considered with renewed interest. By sending probes to study its atmosphere directly or even to float in the clouds, scientists hope to determine the origin of the phosphine and see if the thick, acidic clouds of our neighboring planet might indeed harbor some form of life. In the grand tapestry of space exploration, the phosphine discovery on Venus reminds us of an essential lesson. Sometimes the search for alien life may lead us in directions we never anticipated. Mars, our captivating neighbor, has always been at the center of mankind's fascination when pondering the existence of extraterrestrial life. With its haunting red landscapes and vast valleys, it's a planet that has inspired countless tales of Martians and space invasions. But recently, some real, tangible clues have emerged from this distant world that could hint at the existence of ancient life. The term organic might conjure up images of green foods or farming practices, but in the realm of chemistry, it simply refers to carbon-based molecules, which are life's building blocks. Such molecules are crucial because all known life forms on Earth are carbon-based. In 2018, the scientific community was abuzz with excitement when the Curiosity rover, NASA's mobile laboratory rolling across Mars, discovered organic molecules preserved in Martian rocks. These rocks, located in an area named Gale Crater, are estimated to be about 3.5 billion years old. This discovery means that at around the same time life was gaining a foothold on Earth, Mars had the ingredients necessary for life. What makes Gale Crater especially interesting is that it's believed to have once contained a lake. With the discovery of these organic molecules, one can't help but imagine a past Mars where water-filled lakes or oceans nurtured early forms of life. However, it's important to note that the presence of organic molecules doesn't directly point to life. Mars is a dynamic planet with a history of volcanic activity. These organic molecules could have been formed by non-biological processes or even delivered from outer space via meteorites. Despite the uncertainty, this discovery adds another layer to Mars's already complex and intriguing story. Scientists, with the help of rovers like Curiosity and future missions, continue to unravel the mysteries of the red planet. Each discovery, each hint of ancient water or molecule, draws us closer to answering that age-old question. Are we alone in the universe? For now, the presence of organic molecules on Mars stands as a testament to the planet's potential to have supported life. As we dive deeper into its secrets, who knows what other revelations await us? Far from the warmth of the sun in the chilling depths of our solar system, lie two icy moons that, contrary to their frigid exteriors, might harbor the warmth of life deep within. Enceladus, a glistening moon of Saturn, and Europa, one of Jupiter's largest moons, are more than just frozen celestial bodies. They are worlds of intrigue and promise. At first glance, Enceladus might appear as just another ice-covered sphere, but it hides a dynamic secret beneath its surface. In 2005, the Cassini spacecraft, while exploring Saturn and its moons, witnessed stunning plumes of water vapor and ice particles erupting from the south pole of Enceladus. These geyser-like jets bursting forth into space indicated that beneath its icy shell, Enceladus might be hiding a vast subsurface ocean. Europa, with its cracked, ice-covered surface, tells a similar tale. Observations from various missions and telescopes have provided strong evidence that a massive subsurface ocean, potentially twice the volume of Earth's oceans, exists beneath Europa's icy crust. These observations, coupled with the Moon's induced magnetic field, suggest the presence of a salty, liquid water ocean. But why is the discovery of these oceans significant? Water, as we understand it, is a fundamental ingredient for life. On Earth, where there's water, there's often life. These hidden oceans on Enceladus and Europa offer the tantalizing possibility that, in their warm depths, microbial life, or even more complex organisms could exist. It's incredible to imagine that in such extreme and distant environments, life might find a way. The potential existence of hydrothermal vents on the ocean floors of these moons further amplifies this possibility. On Earth, hydrothermal vents in our ocean's abyssal depths teem with life. These ecosystems thrive without sunlight, relying instead on the chemicals spewed out by the vents for energy. Could similar vents in the oceans of Enceladus or Europa be home to alien life forms? As technology advances, our gaze turns not just to the distant stars, but also to these icy worlds in our backyard. Future missions to these moons aim to study their oceans more closely, hunting for signs of life or the conditions that might support it. The discovery of these subsurface oceans has reshaped our understanding of where life might exist beyond Earth. It's a compelling reminder that sometimes the most exciting mysteries and potentials for discovery lie just beneath the surface. The TRAPPIST-1 system, discovered in 2017, was a breakthrough in our quest to understand the universe and the possibility of life beyond Earth. Situated just 40 light-years away from us, it's relatively close in astronomical terms. When you think of the vastness of space, 40 light-years might seem enormous. But in the grand scale of the universe, this system is practically our neighbor. What makes TRAPPIST-1 truly special is the sheer number of Earth-sized planets it contains. 7 to be exact. These planets are not just any regular planets. They are remarkably similar in size to our own home Earth. This resemblance in size leads scientists to believe that these planets could potentially have similar conditions to Earth, which opens up the possibilities of them hosting life. The most intriguing aspect of these 7 siblings is that 3 of them are comfortably nestled in what's known as the star's habitable zone. This is a region around a star where the conditions might just be right to support liquid water on the planet's surface. As we know, water is essential for life, at least life as we understand it. If there's liquid water, there might be an environment conducive to life. Furthermore, the star at the center of the TRAPPIST-1 system is a red dwarf. These types of stars are cooler and less luminous than our Sun. Because of this, the habitable zone where temperatures could allow for liquid water is closer to the star. This means that the planets in this zone, with their potential watery reservoirs, are in close proximity to their parent star, making them tantalizing targets for future observations. There's a significant effort in the scientific community to study these planets in detail. Using advanced telescopes and observational techniques, researchers hope to decipher the atmospheres of these planets. If they can determine the composition of these atmospheres, they could look for signs of life, or at least conditions favorable for life. The TRAPPIST-1 system, with its Earth-like planets and potential for water, remains a beacon of hope in the search for extraterrestrial life. Deep in the cosmos, in the vast expanse of our universe, there lies a phenomenon that has both baffled and excited astronomers for years: fast radio bursts, commonly abbreviated as FRBs. First discovered in 2007, these are intense, millisecond-long spikes of radio energy that seem to come from very, very far away, and their origins remain one of the most captivating puzzles in modern astronomy. Imagine for a moment a lighthouse. It sends out a quick, powerful beam of light that sweeps across the landscape and then disappears, only to repeat again after a while. FRBs are somewhat similar in nature. They are these extremely short-lived yet incredibly powerful bursts of radio waves that, when first detected, left many experts scratching their heads. The distance from which these FRBs are coming from is astounding. Through various observations and calculations, scientists have determined that many of these signals are originating from galaxies millions to billions of light-years away. To put that into perspective, even the light from our closest neighboring galaxy, Andromeda, takes about 2.5 million years to reach us. That these brief signals from far-off galaxies manage to reach us is a testament to their immense energy and power. But what causes FRBs? That's where the plot thickens. There have been numerous theories. Some suggest that these could be the byproducts of massive cosmic events, like the collision of neutron stars or the eruption of supermassive black holes. Others even proposed more exotic theories, like signals sent by advanced alien civilizations trying to reach out to the cosmos. While the extraterrestrial hypothesis is undeniably thrilling, researchers tend to look for more conventional, natural explanations first. In recent times, some breakthroughs have been made. For instance, certain FRBs have been observed to repeat coming from the same location in the sky. This repeater behavior might provide clues about their origins. Are they from neutron stars in the throes of death? Or are they the result of some other high-energy astrophysical process? The hunt to uncover the mysteries of FRBs is ongoing, with newer telescopes and technologies paving the way for deeper insights. These enigmatic signals from the cosmos might not only teach us about the vast, intricate workings of the universe, but could also offer hints, no matter how subtle, about the possibility of life beyond our tiny blue planet.